All right, let's go over our binomial and geometric practice. Okay, and this also has a warm up similar to your quiz, which does all that binomial and geometric, even though we'll practice more tomorrow. So here we go. We have our first one, our senior athletes who graduate. Okay, so we've got our, it is just asking exactly. So that's going to be our geometric PDF. Okay, so we just did exactly 40 successes, which out of 50, that meant there were 10 failures. So we had PDF. So 5.98% chance, exactly 40 of them graduate. 40 of the senior athletes graduate. Okay, now 35 or 36. So that's going to PDF. So particular 35, particular value 36, and then add those together. So work-wise, you need to show both of those. And then calculator-wise, I did PDF of 35 successes plus PDF of 36 successes. All right. Now, how about fewer than 38? Well, that's going to be an accumulation of that part that is fewer than 38. So here we have our fewer than 38, okay? So remember how important it is to keep in mind, is that 38 included or not? You have got to always be mindful about that bound, included or not. So in this case, fewer than is less than, not equal to. So that means I want to accumulate from 0 up to 37. I do not want 38. I just am going to 37. So notice that my work showed the lower and the upper bounds, and I accumulated the accumulation up to and including 37 because that is what is less than 38. All right. Next is asking about 40 or more. So that is greater than or equal to 40. So that's going to be from 40 up to 50 successes. So the first in my sequence I show is 40 plus ... The last one is 50. Okay, so then here okay, so remember, I think to myself, and I think to myself, what a wonderful world. This is these successes from 0. Okay, remember, I kind of like to show this 39, 40, 41. Okay, I like to show the ones right there around that middle where I'm going to be cutting off things. Greater than or equal to means I want 40 and up. So take off 39 and below. So there's my 1 minus the accumulation of taking off 39 and below. All right, and the next one here, let's see. This one is a geometric probability. What's the probability that the first senior athlete to graduate is the 5th one that I select? So that is telling me the places. It's not saying 5 out of so many. It's not giving me a set number to look at. It's telling me that what I go in all the places until I get that particular one. The success is on the 5th trial. And so then so if you could either just calculate that exponentially here or do your geometric PDF. So let's see. Here we have the probability that the first senior to graduate is within the first 8. So that means that first success can occur on the 8th or the 7th or the 6th or the 5th. So it's an accumulation that first success can occur in any of those first 8 spots. That's geometric accumulation. So that's going to, so let's look at the work you have to show. Okay. I actually do not have to show this second term, just show that first term up to the last term. Okay. And so then that's a success on the first one up to a success on the 8th trial. But then when I calculated it, geometric CDF of 0.72 with the 8th place as the success. All right. And then let's see what I got. This is interesting. I could also think of it as 1 minus the probability that none of the first 8 are successes. None of the first 8 are successes. Okay, that's not registering in my mind right now, but if you had thought about it that way, you could do that as well. All right, next page. Here we have UPS trucks, and 92% of the trucks should pass inspection. So this is interesting. So we've got a manager, and they've got the trucks on the lot. So the first one, what's the probability that exactly 10 of those 25 trucks pass inspection? So think about it this way. um, your upper management, even above that local shipping company person. So you see that the person who's managing that particular location had only 10 out of the 25 trucks pass inspection. Well, is that normal, or is that whoa, very unusually low? So there's something going on there that's unusual. Well, let's see. To get exactly 10 passing inspection is very unusual. Out of 25, keep in mind, out of 25, whatever 92% of 25 is, it's a heck of a lot more than 10, okay? Because 10 is less than even 50%. So there's basically a 0% chance that just exactly 10 of those 25 pass inspection. If I'm corporate headquarters and my local manager only had 10 out of those 25 pass inspections, I'm investigating that because there's mismanagement happening. Okay? That's business. That's business statistics. All right. So taking a look here. Oh, more than 20. So there's a 95% chance that we should have more than 20. So let's think carefully. More than 20 is greater than 20. That means I want 21 successes up to 25 successes. All right, so I'm going to do 1 minus the bottom 20 I will take off because I want 21 to 25. All right, moving on. Here I have got the exactly 2 of the 25 fail. So my success is 0.08 failing. Okay, so I'm going to use that success as 0.08. So I have 2 of the 0.08s and 23 of the 0.92s, and I do PDF for exactly that, 28%. So that's not unusual either. What's the probability that between and including 20 to 24 trucks pass inspection? Wow. Okay, so let's think about this. We could do a bunch of PDFs. So I could PDF 20, 21, 22, 23, and 24. I guess I could PDF those 5 things, those 5 successes, and then add them together. I could also do some fancy accumulation stuff going on. Okay. Oh, yeah. So see, so I could, again, PDF of 20 plus PDF of 21 plus PDF of 22 plus PDF of 23 plus PDF of 24. But I could also then do this. This is interesting. I did, let's see, the highest amount. So I kind of did 24 and down, and then I took off 19 and down. So option 1, you can add together all the PDFs from 20 up to 24. Or option 2, you can take the cumulative of the 24 and subtract off the 19 down. So those are 2 different ways you can think of that. What is the probability the first truck to pass is the 5th truck inspected? What's the probability that the first truck to pass will occur before the fifth truck is inspected? So I guess that means the first truck to pass will be before the fifth one. So that means the first success will happen on the first, second, third, or fourth. Okay. So that placed the first success in a particular spot. So that's the geometric. We didn't say among those four, what's the probability I have certain events happening? All right. So what's the expected? What's the truck is expected to be the first one to pass, and with what standard deviation? So I want to go until I get one to pass. That is the geometric expected. So that's the 1 over P. So you would look on your formula chart at that geometric mean and that geometric standard deviation. And I knew it was in the geometric because I'm going until I get the first one. If you're going until you get that first one, that's geometric. And then what's the expected number in standard deviations out of 25? So that's out of a set number, 25. So that's that happening. That's the binomial mean and the binomial. So keep that in mind. This was that geometric mean and standard deviation. Okay, and then this, nice, that's in white. So let's type in color. So that's the geometric probabilities there because we're going until we get a first success. And then this is the binomial because we have out of a set number of 25 trucks. Okay, so we expect about 23. All right, so then this is interesting. So if the manager will get fired if too many trucks fail inspection. So what would be an unusually low number of trucks to pass inspection? So what low number would convince the corporate headquarters or the upper management to think that the low number of trucks that pass inspection is not just sampling variability? There's something like some kind of mismanagement happening among the staff. So that means I need I need an outlier low amount of trucks passing inspection. So that's 2 standard deviations below what I expect or the average that should be happening. So I do 20, so 23 is what's expected with a standard deviation of 1.36. So I'm going to do the mean minus 2 standard deviations, and I get 20.28. So I have drawn a picture here because this has been an issue with students really kind of following along and understanding what's happening here. So let's take a look. So I don't know if I can zoom. Yeah, there we go. Okay, so think about it. This 20.28 is my outlier threshold, okay? Right here, 20.28. 23 is what was expected. Well, so what's unusual? Is 21 trucks unusual? No, 21 trucks is in the fence. 20 trucks is not in the fence. So if he had 20 trucks or less, if that manager, if they came out and 20 trucks or less passed inspection, that is not just sampling variability. That's not just your bad luck because of you happen to have certain kinds of trucks. No, that is something is going on. There is some kind of mismanagement where you are not taking care of business and you're getting things, you're not taking care of what you need to be taken care of. So 20 trucks or less would be an outlier low amount that do not pass inspection. All right, let's go with this warm up. even though the quiz isn't for another, day after tomorrow, then I'm still wanting you to do this warm up because we just need to practice it so much and we'll have more practice tomorrow before the quiz. All right. Type B blood is 11%. That's the US population's claimed 11% type B blood. Okay. So we've got the blood drive going on here at Aledo High School, and we got our seniors who are over 18 that are donating. So you go and you work that the Carter blood drive. How many blood donors should the American Red Cross? Oh, it's the American Red Cross blood drive. How many should they expect to collect until they find a donor that has type B blood, and with what standard deviation? We are going until we get a success. And how many do you expect? Expected value is the mean. Expected value is the mean. Geometric 1 over p, binomial n times p. So here I have a geometric situation because I'm going until. So my formula chart says that the geometric expected value is 1 over p. So if we take a look at that here, I'm going to zoom in so we can see that. My geometric mean is 1 over p with this standard deviation here. And remember, geometric is going until we have that first success. All right, next. Then we've got this happening. We're going to say, what is the probability that the 10th donor is the first one who has type B? Well, that means that 9 of them are not successes, and then the 10th one is. So I did geometric PDF, or you could just multiply that out there. All right, and next, exactly 2 of the first 20. So that is a set number of 20. Look at 20, and those 2 successes can be sprinkled anywhere amongst those 20. So then that's our binomial. So we've got 20 trials, 2 successes. PDF, exactly 2 successes. All right. Oh, now look at here. What's the probability that at least 2 of the first 10 donors? So I have got a set number of trials. So I know my n is 10. Just like on that previous problem, I knew my n was 20. So that was, again, why I know I have a binomial situation. Okay. But I want at least 2. So at least 2 means I want 2. I want 2. Remember thinking, do we include it or not? Yes. I want 2 up to 10. And so then remember, my calculator will not accumulate an upper part. So it will not accumulate an upper part. So I do 1 minus the lower part accumulation. 1 minus the accumulation, and I'm going to take off 1 and below. So I take off 1 and below. All right, and then my next one here, I have got 150 seniors that show up to the blood drive. So out of those 150 seniors, how many do you expect to be type B? So what are they anticipating getting from this blood drive in terms of type B donors? Well, that's my binomial. It is a set number of 150. So that's a binomial situation. N times P is my expected number, about 16.5, with this standard deviation of 3.82. But look here, this is interesting. This is kind of like the last problem on the previous page. So we got a really low amount. I mean, we had the whole 150 seniors come, and we ended up getting what we think is a really low. We're like, whoa, that is not what we expected. We were hoping to get about 16 and a half donations of type B blood. So that makes me start wondering, is this area is East Parker County. Does it really have 11% type B blood in this area? Unfortunately, we're pretty homogeneous here. We do not have a good cultural mix like the United States. And so, while there may be 11% type B blood, if there's, certain, if the type of blood, which I don't know, you have a certain tendency to have that based on certain races or ethnicities and that kind of thing, then maybe we do not have the typical rates as other areas in the United States that are a better mix or a more varied mix. So I want an outlier low amount would make me be surprised. So I'm going to take that expected value of 16 and a half and subtract 2 standard deviations. That gives me 8.86. All right, but remember that we struggle with kind of like finding, okay, well, where am I at on that? So I have a picture. And always think of a picture. Draw a picture. Draw a picture. So 16.5 is what's expected. That's the mean. But my outlier fence is here at 8.86. Okay. So where would the lower part, where would unusual be? Is 9, if I had 9 donors, is that unusual? And that answer is no. It's on the edge of unusual, but no, 9 is not unusual because that is inside the fence. 8 or less donors would be unusual. Okay, so that's where we would consider it strange. So that's what we got going on here. We say if I had 8 type B donors or less, I would be surprised and I would think, whoa, I'm not so sure that we actually have 11% type B donors in this area. Okay. All right. I think that was all of that assignment. Some really good thoughts on that. I hope you understand that last topic about the unusual amounts that make us call into question the rate that has been previously claimed. All right. Good luck to you on your next assignment in probability.